Everybody, and welcome to this video all about how to make the graphs for your integrated rate laws. I just thought it would be easier to make a quick video rather than to type all this out. I think it's easier to see somebody do it than to actually read on how to do it. So I am actually going to do number 2 that's on this Intro to the Integrated Rate Laws worksheet. So you can actually follow along with me for that. And that way for number 3, you can just do that one the same exact way. So the first question says determine the rate law. So we have to find the rate law for nitrogen dioxide. What I typically like to do is I just like to input my data that's given to me. So I have time in seconds, and then I have the concentration of NO2. You don't have to be specific with units and all that, but normally I just like to put something there so I know what that equals. And then I'm just going to input each of my values. I'm not putting them in scientific notation. I just think it's easier to put it as whole numbers. So let's input these. There we go. And now let's input our concentrations. So if we were to plot this as it is, if this were accurate, we would see if this would give us a 0 order reaction, because time versus just the concentration, if that is a straight line, means that this is a 0 order reaction. The way you would make a graph is you go to Insert, and I'm going to go to Scatter, and you could see here that here is our graph for that. So we have time on the bottom versus concentration of NO2. As you could see, this really is not a straight line. And the best way to determine if it's straight or not is you can add a trend line to that. And if you display the equation and the r squared value, notice how the r squared value really isn't that close to 1. I mean, it's within 10%, but it's really not a very good straight line. So just judging from that, this is not a 0 order reaction. So we do have to continue. In order to determine if this is first order, what we would need to do is to find the natural log of the concentration and plot that versus time. So let's go ahead up here and just do ln of NO2, just to show that that's what I'm finding in this section. Excel does all of the work for you, which is great. So if you just type an equal sign, and you type ln for natural log, and you'll see that a little equation pops up. You do a parenthesis, and you click on the value you want the natural log of, which is the concentration of NO2. Press enter, and you get that value right there. And rather than typing this the same for each of those, if you just pull down, it actually finishes those for you. Let's make a graph of time versus seconds versus the natural log. What you want to do is highlight time in seconds, and you want to press Control and highlight this guy right here. So I'm skipping over this NO2 section right there. Once I get that, I'm going to do the same thing. Let's insert a scatter plot, and I have something like this. Notice how K for both of these is in fact negative. It's hard to tell again if it's a straight line, so I usually just like to add a trend line. Let's display the equation and the r squared value, and I get that guy right there. I think it's easier to see without these grid lines. So this one looks more like a straight line, but actually it's still not 100% straight. So this doesn't really look like it's first order to me either. Let's go ahead and do this last one just to double check. So to know if this is a second order reaction, we want to take 1 divided by the concentration of NO2. And to do that, we're going to do the same exact thing. We're going to set an equal sign because Excel does all the work for you. we just want to go 1 divided by, and I'm going to click on the concentration of NO2 again because I want 1 over that concentration. And press equal, and I get 2. Highlight back on that, get the little crosshair going, and I'm just going to pull down, and Excel does all of the work for us again. Let's go ahead and plot time versus 1 over the concentration of NO2. So again, I'm going to highlight and pull down, and I'm going to press the control button, and then I'm going to highlight that section right there. And same thing, let's insert another graph. And here's my graph for this guy right here. Again, kind of hard to tell if it's linear or not. I think the best way to see is by adding that trend line. So let's right click, add trend line, display equation, display R squared value. And this R squared value is our correlation coefficient. Again, the closer that value is to 1, the straighter your line is. So just by looking at those R squared values, you can clearly see that this last graph is our most linear line. Therefore, the rate law for this particular reaction would be that rate equals K times the concentration of NO2 squared. And that's because we just determined that this is a second order reaction. I'm going to try to make that a superscript. So if you wanted to make a superscript in Excel, it's kind of a pain in the neck, but you can format cells, do superscript, and you can actually do the same thing for a subscript here. So let me highlight that, format cells, subscript, boom, there it is. So I believe that's the answer for A right there. Determine the rate law. And we just did that using graphical analysis. Really not a difficult process. It just takes some practice, I think, to get used to. And we did that relatively quickly just now. So I'm not going to edit this. It just is what it is. I'm sorry the sound quality is bad. I'm doing this on my school computer. I also am not 100% sure how to do it on the iPad. So if you do this on the iPad, I would try to kind of play around with it a little bit just to see how to do it on there. But as long as you know how to do it, I think in general, you can kind of figure it out on the iPad that way. And of course, if you're in the room, you can always do it on one of the desktops in here, or if you're at home, you can do it on a laptop or on a desktop. And it's nice because with your school account, you can actually download the real Excel and Word and all that on your home computer, which is great. You have free access to those. That's a lot of money you're saving. So anyway, I hope that helped. This answers question 2A on that worksheet you're doing today. And you can use that, of course, for 3A as well. It's the same exact thing. I hope that helped, and I will see you guys later. Bye.